So our system was built by four of us. I work on the front end, and Bumeega took care of the back end with Ballerina. And then she created the machine learning classifier, and Nethmini handled the database and caching. So all together, we built a full fraud detection platform from start to finish. A frontend is built using React, providing a fast and interactive user experience for the front-end system. It allows users to easily submit a job posting for analysis, view results, and navigate through a clean, modern interface. The design focuses on simplicity and clarity mainly, making easy for everyone to check job posting for potential crash. Hello everyone, I'm going to demonstrate the front end of our fraudulent LK system, a React-based web application that helps to detect fraudulent job posting. Let me first run the application front end. Notice the modern, clean design with semi-transparent header, with backdrop blur and gradient backgrounds, and especially smooth transitions. This all built with React 19 and modern CSS. The interface has main three sections: analyzer, feature, and about. When we consider the core functionality of this fraud analyzer, user can input job description and image of the job post to see the to check the fraud. The form uses React state management with use state hooks for real-time updates and error handling. Behind the simple interface is sophisticated React architecture. So our main app.js here, components manage the navigation states like that, and the job form components handles multiple states, form data and image upload, loading states, and the results. So we use the fetch API to communicate with our Ballerina backend and with comprehensive error handling for smooth experience. So mainly this React frontend seamlessly integrate with our Python ML model and Ballerina backend.
Hello everyone, my name is Bumeega and I was in charge of handling the backend part. So I have used Ballerina to integrate my backend and extract text from the image use an OCR method and feed that data to the machine learning model. So basically, the main.bal, which is the file that I'm opening here right now, is the sort of like the heart of our project, which defines the HTTP API endpoints using the Ballerina service syntax. And also it handles the request of fraud checking and OCR extractions, which I will go through one by one, discuss in this file. So as you can see the imports here, they bring in the Ballerina's built-in modules for HTTP APIs, files and operating system operations, logging, string handling, and other, and also the MySQL database actions. See, so as for the configurable, the files you see in here, basically what they does is these variables allow you to configure the backend connection to Python scripts and the database, as well as enabling and disable of OCR, and as such the database connection will be explained right down below. So as you can see, there are some data structures here which we use for API request and responses, ensuring the type, safety, and also the clarity. And let's move downwards, and we get to the function get tmpdir, which I have used to find the system temp directory, and also the function normalize for hash right here. So which actually normalize the input for hashing and also for the utility functions for working with the file paths and preparing the data for caching. There is a MySQL client section. It sets up the cache service and initialize the MySQL client and the cache service using the Ballerina database module. As moving forward, now we have the HTTP listener 1991, which is actually defines the main HTTP service using the Ballerina service-oriented syntax, as you can see here. So what this does is it gets a simple get endpoint to the verify the backend is running. This integrates with the cache and also sort of like being as the bridge between the machine learning model, and handles also the errors and the log events. As for the resource function post, extract text part here, what it does is it actually accepts an image file in the multi-part request and also extracts the image part and calls the OCR bridge, returns the extracted text as a JSON file. This is sort of like the bridge to the entire section with the Python machine learning model. Writes whether we writes the job data to a temp file and also executes the Python machine learning script using Ballerina OS EXEX, and also reads and interprets the results and cleans up the temp files. The seamless integration with external Python scripts using Ballerina should be highlighted definitely, and also strong error handling and logging, also one great feature of Ballerina which we have used in this code. The remove temp file path here, and also the fraudulent check and retrieves the results here. So as you can see in this code, right, and removing the temp files here. This section actually explains the OCR bridge, and as we move on. So that's the first section. In here we have all the dependencies of using Ballerina, so the Ballerina .tml file. But this is the basic structure, and as you can see, these are the files that we have, and that's for my part.
Hi, I'm Dhanuja, and in this part of the project, we are using a machine learning model to detect whether a job advertisement is fraudulent or legitimate. The text of a job ad, for example, the title and description, is first cleaned and pre-processed. Then it is converted into numerical features using TF-IDF, which highlights suspicious keywords and patterns. These features are given to our trained classifier, which predicts if the job is fraudulent or legit, and produces a confidence score. Then the prediction is then stored in a database, and so that if the same job ad is checked again, we don't need to rerun the model, we can fetch the results directly from the cache. This makes the system both fast and reliable.
So this file is what we use once the model has already been trained. The idea is simple. Whenever new job ad comes in, the script checks if it's real or fake. First it cleans up the text. It lowers everything, stripes out links, symbols and common filter words. Then instead of training a model again, it just loads the model and vectorizer we already saved earlier. The clean text is transformed into numbers with the same TF-IDF method and then passed into the model. The model makes its prediction and return either 0 or 1. 0 means job post looks legitimate and 1 means it's likely a scam. That's all this script does. It takes in fresh text, processes it the same way and instantly tells us whether it's fraud or not. This code is where we train our machine learning model to detect scam job advertisements. It begins by loading a dataset of job ads and preparing the text so it's easier for the computer to understand. That means cleaning the text, removing unnecessary words, links, and characters. After that, it doesn't just rely on the text itself. We also add extra signals that are usually found in scams, like whether the ad mentions money, has too many links, phone numbers, emails, or uses suspicious keywords such as work from home or instant payouts. Once the data is ready, we convert the clean text into numbers using a method called TF-IDF and then combine those numbers with extra features we created. Since scam ads are fewer than real ones, we also balance the dataset using SMOT so the model learns fairly from both sides. Finally, we train an XGBoost classifier, evaluate how well it performs, and then save the trained model, the vectorizer, and the thresholds into files. This means we don't have to retrain it every time. We can directly use these saved files to classify new job ads later on.
This is the evaluation of our model. The confusion matrix shows that it correctly identifies almost all real jobs and most fake ones. This is the evaluation of our model. The confusion matrix shows that it correctly identifies almost all real jobs and most fake ones, with only a few misses. In the classification report, we can see precision recall and F1 scores, all very high, giving us around 99% accuracy. We also tune the decision threshold to catch more scams, even if it means a few false alarms. The best threshold was about 0.16. Finally, the average precision score is 0.94, which shows the model is performing really well.
Hi, I'm Nethmini. I handle the database and caching system using Ballerina and MySQL. Each job post is stored with a unique SHA-256 hash generated from its text. When a new request comes in, the backend first checks this cache. The result from the model is inserted into the database, an upsert operation. So the latest result is always else. To build our cache module, we first import two built-in Ballerina libraries, SQL for database access and Crypto for hashing. Because these are native to Ballerina, we don't need extra dependencies. Cache row. It directly matches what we want from the database, the classification and its confidence score. So now that we know the data structure, we need a place to manage it. That's where our cache service class comes in. It is declared as isolated, which means it is concurrency safe. That is very important because many users can make requests at the same time. So inside it, we keep a reference to the SQL client. This client is injected when the class is initialized. So every method can access the database directly in a safe and clean way. Once the service is ready, the first thing we do with the job ad is generate a unique fingerprint for it. We take the text of the ad, convert it to bytes, and then apply SHA-256 hashing using Ballerina's crypto library. The result is a 64-character hex string. This hash is our cache key, so if the same ad ever appears again, we can instantly identify it. In other words, if I say different ads always generate different hashes, while identical ads always map to the same one. Parameterized SQL query to look up the hash inside our job post table. There are three possible outcomes. If we got a cache row, that means it's a cache hit. So we can immediately return the stored classification and confidence. Then if we get no rows error, that means it's a cache miss. Then we need to call the ML module, and if something else goes wrong, it handles as an error. This structure keeps our logic safe, predictable, and very efficient. So then, once the ML module has given us a result, we don't stop there. We also make sure the system learns from it. So for that, we use store result function to insert the hash, input type, original input, classification, and the confidence to the database. And here's the important part. In here, we use an upsert with on-duplicate key update. In normal operation, if the ad was already seen, the cache will return the result instantly. So we won't even call ML module. The update clause is a safety net. This keeps the database clean and always up to date. If it ensures that repeated job ads are handled instantly, new ones are analyzed through machine learning module, and our whole platform stays fast, efficient, and reliable. This diagram shows how our system processes a job advertisement from the moment it's uploaded until the result is displayed to the user. The process starts at the React frontend, where the user uploads either text or an image of a job post. This request is then submitted to the backend. The Ballerina backend receives the request. If it is a plain text, it moves directly to the next step. If the input is an image, it passes through the OCR model, which extracts the text. Once we have the text, the Ballerina backend generates a hash key for it. This acts as a unique fingerprint for the ad, so we can instantly recognize if we have seen it before or not. With the hash key, we check the database and cache. So this ensures that if the same ad appears again in the future, the result can be retrieved instantly. Finally, the backend returns the result to the front-end user interface, where the user can see whether the job is fraud or legitimate, along with the confidence level.